Hello and welcome to this Altech Corporation webinar. My name is Matthew and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you'll see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenter. With us today is Marcus Kreis, the Product Manager for Altech Corporation. To read more about Marcus, please look at the Speaker Bio window right next to the main presentation window. And Marcus, welcome to today's event. And with that, I will pass things along to you to get started.
Hello everybody, thank you for joining our webinar today. Today we'll discuss DIN rail terminal blocks. How do I choose the right terminal block in different industries, and also how do I use them in different applications. My name is Marcus Kreis. I'm the product manager here at Altech for terminal blocks for over 10 years. I hope you enjoy the presentation. If you have any questions, please type them in and I will answer them at the end after the presentation. To give you a short overview of my presentation, so I will start with the different terminal block types, what's available in the market, how do they function, how are they used. Then I will get a little deeper and discuss the different connection technologies within the DIN rail terminal blocks. There's screw technology, spring technology, push-in technology, and ring lock or stud technology. And also I will go over what we as Altech have to offer when we talk about DIN rail terminal blocks. So the original and still most commonly used terminal block, it's called a feed-through terminal block. That is used for connecting incoming wires, for example, into a panel and then distributed within the panel. As you can see here on the picture, there's one terminal on one side of the terminal block where a wire is connected, and that terminal is then connected through a current bar to the other side of the terminal block where there's another terminal, and here the outgoing wire that's distributed into a panel is connected. These feed-through terminal blocks, they are usually available in all kinds of different colors. There's blue, black, red, orange, white, yellow, green. However, gray is usually the standard, and that's most commonly used. The different colors, they exist to differentiate maybe different voltages, different amperages, different components that are connected to it. Neutral wires, for example, usually have a blue terminal block. Also, the highest available feed-through terminal block with Altech is a 240 amp terminal block, which can connect up to a 2-aught wire. A special form of feed-through terminal blocks are so-called grounding or earth terminal blocks. They are used to mechanically and electrically make a connection between the wire and the DIN rail. How this happens is, so the wire is connected to a terminal, and then the terminal is connected through a special clamping mechanism to the rail itself. This allows the rail, for example, to function as a bus bar. These grounding or earth terminal blocks, they're color coded, and their color is usually it's yellow-green. Here at Altech, we have two different versions. So what you can see on the right, that's a screw down version where you have a top center screw, and by that screw you screw the grounding or earth terminal block down onto a rail through a clamping mechanism. The other option for a grounding or earth terminal block we have are so-called snap-on versions, where you don't need a tool and the terminal block is just like a regular feed-through terminal block snapped onto the rail, but you still have your grounding or earth connection between the terminal block and the DIN rail. And another form of feed-through terminals are either multi-connection or multi-level DIN terminal blocks. So here, compared to a regular feed-through terminal block where you have only two connections, here you can have 4, 6, 8 or more connections. And these terminal blocks, they are usually used when higher density wiring is needed, because there's some spacing issues or spacing limitations in the panel. So what you can see here, there's double level terminal blocks, for example, there's triple level terminal blocks, there's even 8 level terminal blocks. There's different versions of all of these versions. Sometimes both levels are shorted. There's versions of the triple level where all 3 levels are shorted. The 8 level can be shorted. Another feature is available within these multi-level terminal blocks. There's grounding options built in on some of them. And many of these 3-4 connection terminal blocks, they're, for example, used for distribution purposes. So you can have 3, 4, 5, 6 IOs within one terminal block, and there's usually different solutions depending on available height or width of panel space. For example, a 4 connection terminal block, as you can see down here, with 2 in, 2 outs. Technically, it is the same as I have a double level terminal block, which is shorted in the center. A very large group of function blocks within the DIN blocks are the fuse terminal blocks. So fuse blocks, they are usually used where you need some protection, and they can provide that protection, for example, for output devices of PLCs or all kinds of other modules. And obviously they are used for safety purposes in case of something goes wrong in your circuit. And their advantage is that they have a fuse inside, and that fuse can easily be replaced after the fuse blows. There's 2 common fuse types that are used in fuse terminal blocks. So one is 5 by 20 millimeter fuses. These fuse blocks are usually a little bit more compact and smaller than the other fuse size terminal blocks, which is a 1/4 by 1 1/4 fuse size. Obviously the fuse is a little bigger, so also the fuse terminal block is a little bit bigger, but these two fuse sizes are the most common. Another fuse type which is available is fuse terminal blocks, for example, for automotive fuses. All these fuse terminal blocks, they usually also come in versions where you have a little LED on top, and that LED is used as an indicator to give you the fuse status. There's different voltages available for these fuse indicators, and the most common ones are either 24 volt DC or 110 volt AC. The fuse terminal blocks, they are actually already one type of disconnect terminal block, but there's a different group of disconnect and test terminal blocks with which you can disconnect the circuit. So those disconnect and test terminal blocks, they are an easy solution to enable circuits to be opened and cut from its power source without having to shut off complete power system. Blocks, sometimes they need to be disconnected for maintenance or other test and measurement requirements. There's very many different kinds of disconnect and test terminal blocks. They usually differentiate in how they are disconnected. There's knife or blade disconnects, which you can see here at the bottom, but then there's also versions which have like a slider in the middle to open and close the circuit, or there's lever versions as well. Some of these disconnect and test terminal blocks, they have accessories available, for example, add-ons where test probes can be inserted for easy access for test requirements. Applications, for example, here are when meters need to be replaced. Utilities use these kind of disconnect and test terminal blocks. I have seen them in transformer applications. Also, there's quite a few accessories available with these disconnect and test terminal blocks, which give, for example, the options after the circuit is disconnected to temporarily create a short circuit between different lines for testing purposes. Another group of terminal blocks are distribution terminal blocks. And as the name suggests, they're used for simple distribution systems, distribution applications. These terminal blocks, usually they come in various I/O configurations. They're available in 2, 3, 4, 6, 8, 12, 24 I/Os. Some of them have a larger input terminal, so high current inputs, and then smaller currents can be distributed to the outputs. These distribution terminal blocks are used, for example, for phase distribution systems, certain motor applications, and very simplified distribution systems within panels. A very special group of terminal blocks are the so-called thermocouple terminal blocks. Thermocouple terminal blocks, they consist of two terminal blocks combined. However, they're not regular terminal blocks. Each of the two terminal blocks has different materials on their internals. Yeah, so the current bars consist of different materials because what is a thermocouple? A thermocouple usually consists of two wires or wire legs, and they are made from different metals. So these legs, they're welded together on one end into a junction, and that is where the temperature is measured. Now on the other end, a voltage is created between the two wire legs when the junction senses a change in temperature. And this voltage then can be measured, yeah, at the terminal block, for example, and that voltage then can be interpreted using certain thermocouple reference table, and these reference tables, they can be used then to calculate the actual temperature. Available here at Altech are thermocouple blocks, yeah, of different types, and each type stands for a different metal combination. There's the K type, J type, T type, and E type. And as you can see here on the slide, each type then has different materials. At least out of my experience, the most commonly used ones are the K and the J type thermocouple terminal blocks. And the last type of terminal blocks I wanted to discuss and get into here are the electronic terminal blocks. Electronic terminal blocks, usually they utilize existing double level or multi-connection 3-4 connection terminal blocks, and then some kind of electric component is wired or soldered into that terminal block. It can be, for example, an MOV, to give the MOV an easy connection point to wire it instead of soldering. So you can see one, for example, here on the top picture where the MOV is soldered into the terminal block, and then the legs of the MOV can be accessed through a double level terminal block. Other examples are double level terminal blocks where there's different diodes wired into the terminal blocks. These are used, for example, for reverse polarity protection, or some of them have also certain resistors, other diodes soldered into. They can be also used for AC, DC voltage indication or certain equipment protection. After discussing now the type of terminal blocks, we now come to the three main connection technologies for thin film terminal blocks: the screw, spring, and push-in technology. From a historical point of view, the original terminal blocks, they were invented with screw clamps, so that was the original connection technology. Later along came the spring clamp technology, and the newest technology in the market is the push-in technology. Some also know it as push to release. When we look at a screw clamp terminal block, these are usually the most cost-effective options from a technology point of view. That's why usually a screw clamp terminal block is more economical from a pricing point of view than spring or push-in terminal blocks. how is a wire connection made? So we have a clamp, and there's a screw, and by tightening the screw with a screwdriver, that tightens the clamp and tightens down the wire which is inserted in a box clamp. However, when we make that connection, we need to watch out that we have a safe connection. We don't want to over torque the terminal. This could strip the screw or break the terminal completely. So we would have a loose wire, or on the other end, we also need to make sure we have enough torque. If we don't have enough torque, we could also have a loose wire in the terminal. Now the spring or cage clamp technology. Here we have a preloaded spring, and by inserting a screwdriver into a slot, we open that preloaded spring. That screwdriver pushes the spring away. Then we insert our wire into the clamping space. You remove the screwdriver, and the conductor automatically makes contact then with the terminal. This way we have a connection in just a few seconds. Now the push-in technology, as the word push-in already says, just by using the force of the conductor, that you generate pressure on a spring, which is usually made of a high quality stainless steel material. You open that spring automatically, and just this way, by pushing in your wire, you make a connection. You do not need any tool or any screwdriver for that if you use a solid conductor or you have a wire with a ferrule on it. This is the fastest connection technology, but as mentioned before, push-in technology terminal blocks, they're usually a little bit more expensive than screw clamp terminal blocks, just because of the technology itself. Another special type of screw clamp terminal block is the fork or the ring lock terminal block. I'll get into that a little bit later. And also on our website, altechcorp.com/dinblocks, you'll have some videos which show the connection and how these connections are made in more detail if you're interested. For screw terminal blocks, Altech carries two different series. So what you can see here, that's the Altech CT series, and that is the original series of DIN rail terminal blocks that Altech carries. How it differs now from the other series is, here we have a screw-in jumper system, whereas the other series compared to this one have a push-in jumper system. The strength of the CT series is in the large variety of available terminal blocks. All previously mentioned terminal block types are available in many variations. What you can see here, starting from feed-through terminal blocks on the left in all various colors. Then we have multi-connection and multi-level terminal blocks, different fuse blocks, disconnect blocks, and also then the special blocks I mentioned before, like thermocouple blocks, and also a lot electronic blocks are available. Now, compared to the CT series, all the other series which we carry, they cover all connection technologies like screw, spring, and push-in technology. That's our CY, CX, and CP series. And they all utilize the same universal push-in jumper system. So regardless of the series, it's always the same jumper, which makes it then much more convenient to keep inventory, because you have a lot less part numbers than if you would have a different jumper for each series. Some of the features of that universal jumper system, it includes various pole configurations. The jumpers are available, for example, in 2, 3, 4, up to 16 poles for most of the sizes. Also, larger pole counts can be cut to the desired number of poles if one specific pole configuration is not readily available. Also, it's possible to stagger jumpers because most blocks, they have 2 jumper channels. So for example, 2 3-pole jumpers can be overlapped in a way they make up a 5-pole shorting link. And also the design of the terminal blocks and the jumper together, it allows then the step-down jumper to be installed. Step-down jumper means you create a shorting link from a larger to a smaller size terminal block. Screw technology is covered by our CY series. That's what you see here on the slide. What stands out on the CY series? It's very strong clamping system. Also, terminal blocks of this series are made from a high quality V0 material. From the very smallest block up to 10 square millimeters, all blocks have the same profile. That means all terminal blocks, they utilize the same accessories such as end plates. So you need to keep less inventory. End plates, for example, they fit with different size terminal blocks. Also, overall, the series covers all the basic blocks we mentioned earlier in the presentation. So there's our feed-through blocks, 3-4 connection, double level, triple level. We have fuse blocks and also disconnect terminal blocks. Central part of the CY series, that's the CYDL multifunction terminal blocks. That is a double level terminal block, and it gives you also the option to have a ground terminal at the bottom. The top level can be either a fuse, a disconnect, or a feed through. The mid level is always a feed through terminal. Where this is used, for example, is instead of having a fuse, a feed through, and a grounding terminal next to each other, here all these 3 functions are built into one terminal block, and that allows to have approximately 60% in space savings. Where do we see these terminals? We see them in large quantities, usually used either in the oil and gas industry and also with DCS systems. Spring cage terminals, they're represented by the CX series. They're maintenance free since there's no screw to be tightened. The stainless steel springs, they guarantee a safe and secure connection. What makes this series then especially interesting for elevator and escalator industry, and that is out of our experience where they're mainly used. Of course, in the CX series, all basic block types mentioned earlier are included. Feed-through, multi-connection, double level, fuse, and disconnect terminal blocks, they come in different variations, as seen on the sample rail assembly here on the slide. And it also has the ability then to utilize the universal jumpering system, which I discussed earlier. There's a couple of parts of the CX series which I want to point out. One is the pluggable terminal blocks. That's used for easy connecting and disconnecting wires. For example, when there's components or modules in a panel that need to be removed from the system and plugged back in. One side is the plug, which is modular. There's single block modules. They can be stacked together to the desired numbers of wires to be plugged in. And these plugs then can be plugged into a DIN rail feed-through base for a wire to DIN rail connection, or also possible it can be a free-floating wire to connection which is not mounted on the rail. The other unique block of the CX series is a hybrid distribution block. Hybrid because for the high current input it has a screw terminal for a strong connection, and the outputs have spring connections for fast and easy wiring. The whole system is modular, which makes it then expandable in its output with regular feed-through terminals and regular jumpers. It's a great block for small, simple distribution needs inside a panel. Now the third and the latest series, that's the CP series, which covers the push-in technology. There's no tool required for wiring. Wires are just pushed into the terminal for a safe and secure connection. To release wires, this is done with a little orange push button on top of the terminal block, which can be accessed with any kind of tool. And besides the universal jumper system, the series features all the main terminal block types we discussed before. And what's unique now with this series, the design of the push-in spring now allows terminal blocks to be designed very compact, very small. The smallest terminal block we have available is only 3.5 millimeters wide, and as of now, that is the most compact DIN rail terminal block currently in the industry. And this compact design I just mentioned, that's the basis for two of the block types included in the CP series. One of them you can see here on this slide. That's the sensor and actuator terminal blocks. Since this is mainly low voltage, there's usually no high current requirement, and also the wire sizes are small. Then space is significant when a large number of sensors are used and connected together. And that's when a very compact, very small terminal block is needed. What you can see here is you have in the center, there's a larger power input terminal in the center. And then to the left of and the right of this power terminal block, there's compact 3.5 millimeter wide sensor terminals, and they can be added as needed with color-coded blue or red jumpers. And also, if needed, there's a grounding option available. And also the sensor terminal blocks, they come with status indicators, which indicate the status of the sensor if it's on or off. The other very compact block type within the CP series, that's the 8-level marshalling block. Here you can see that on the slide. It has 32 connections, compact, built into one terminal block. It has 8 levels, with each of the levels having 4 connections, 2 on each side. There's a couple variations of this terminal block, where one variation has the 4 upper levels shorted and the 4 lower levels shorted for 2x16 connection then, or another variation of the terminal blocks, you have all 8 levels shorted and then you have 32 connections on the same potential. One of the most common applications for the marshalling block is, for example, potential or signal distribution. A special form of screw terminals are stud terminal blocks. These terminals accept fork and ring lugs. There's many different designs available. Some are open type, some have protective covers. And it's especially high current systems which also see a lot of vibration. They utilize these terminals, which some of them have current ratings up to 500 amps. The terminal connections are very strong and secure. First, because of the ring lugs that are used to connect the wires, and also because of the high torque values of the terminals. It's the power industry and the railroad, for example, which are typical industries where these type of terminals are used. Besides the terminal block themselves, there's another important part of a DIN rail system which we haven't discussed yet. These are the accessories. Accessories, complete a DIN rail terminal block system. Some have safety functions, others make the system more convenient for the end user. First of all, there's the end stops. They're usually mounted on each side of the DIN rail. They come in different sizes, and what they do is they prevent DIN rail terminal blocks and other components such as power supplies and breakers from shifting back and forth on the rail. End plates, they cover open ends of terminal blocks and make the system then touch-proof. Separator blades are similar. They provide visual and electrical separation of different groups. Another function they can have is they prevent the ends from cut jumpers to touch each other. Jumpers we have discussed before. They're used to electrically interconnect two or more terminal blocks. Marking tags are very important. They come blank and they can be imprinted for better identification of wires and terminal blocks. Protective covers are provided for safety when open terminals are used or uninsulated jumpers. And also for some terminal blocks there's test plugs available, and test plugs are usually inserted into jumper slots, and what they do is they provide options for test probes to be inserted for various test and measurement purposes. In the last part of my presentation, I'll discuss some selection parameters which help us identifying and specifying a DIN rail terminal block system. So first, we need to know the number of circuits we have and IOs. Then we can decide the types of terminal blocks. That depends on other components in the systems, what functions they have. It can also depend if the circuits, for example, need to be accessed for testing or other measurement purposes. Many terminal blocks, they come usually in different sizes. The size by a terminal block is determined by its required voltage and current ratings. And also important is the wire size or what wire types is used. We want to make sure the needed wires, they fit into the terminals, and also we don't want to oversize the terminal blocks to keep the whole system cost effective. When we have all the terminal blocks selected, we can choose our necessary accessories. This can be any needed end plate or partition plate. Maybe some spacers are required because of higher operating temperatures of some of the components. And either at the beginning, before we do all this, or once all is selected, is done, we can weigh the pros and cons of the different connection technologies we spoke about before. Reasons to choose one technology or the other can be coming either from the application, or it can be also coming from the installation point of view. To give another quick overview of the connection technologies, what we discussed before, all three of the technologies, our CY, CX, and CP series DIN rail terminal blocks, they all utilize the universal push and jumper system. The screw clamp technology, it's been around for a very long time within the DIN rail terminal blocks. It has itself long time proven in the industry. Also, it's the most cost-effective of three technology when we just look at part cost itself. Everybody's used to the technology since only a screw has to be tightened. However, there's some time involved to tighten the screw to secure the wire, and also torque settings are important. Now, spring cage technology is torque independent. A safe and secure connection is made in just a few seconds. If a pluggable system is needed, this could be the choice within Altech's terminal blocks. However, we still need a tool. Now, push-in technology is the newest of all three technologies. There's no tool needed, and connections, they're just made by connecting a wire directly to the terminal. As far as installation goes, the CP series provides the most time savings, which is very significant, obviously, if we have a system with many IOs. Also, push-in technology should be the choice for low voltage systems when we have small wires. Here, it is the most compact, and besides time savings during install, here it also provides the most space savings as well. This was it for my part for the webinar today. Thank you for joining me. And as I mentioned earlier in my presentation, if you have any questions, please type them in, and I'm happy to answer them for you. Thank you.
Thank you so much for that great presentation. And now we're going to be moving into the Q&A session. We do have some questions that have come in from the audience, so we're going to move into answering those in a moment. If we don't get to your question, don't worry, we will have an answer for you following the webinar. And if you haven't submitted your question yet, you can still do so now by entering it in the Q&A box and clicking submit. We'd love to hear if you have a question or if you have a comment. We'd love to hear from you. Okay, now for our first question from the audience. Which connection technology is mostly used in the industry? Marcus?
In the US, it's definitely mostly screw terminal blocks. However, we see growing numbers in push-in terminal block technology. For example, in Europe, it's a little different. Spring and push-in terminal blocks have a bigger market share over screw terminals than here in the US.
Excellent. Thank you for that. Okay, and our next question from the audience is, okay, here it is. In which industries are Altech terminal blocks currently being used?
They're used in pretty much every industry where wire connections have to be mounted on a DIN rail. Large industries for us are automation and control, power industry, utilities, HVAC, refrigeration, machine building. We see our terminal blocks in the oil and gas industry. Transportation, where rail industry, for example, this is another example.
Quite a bit. Great question, too. Thank you to the audience member that sent that in. And to the audience, we are in the Q&A session, as mentioned. You can send us your question by adding that to the Q&A box and clicking submit. And while you're thinking of your questions, I just want to point out on your screen, in the top right corner, we have the resource list, and there's multiple links and some PDF documents that you can download. And we encourage you to continue the conversation and look into that. Okay, back to the questions. Here's our next question from the audience. Are colors available for the different types of terminal blocks?
Yes, colors are pretty much available for every terminal block. There's larger stock, for example, for regular feed-through terminal blocks, double level, triple level terminal blocks, fused terminal blocks. However, colors, any colors available for every terminal block. Some other special terminal blocks as well, and they're available on request then.
Excellent. Thank you for that. Okay, and moving on to our next question. This is a great question. Here it is. With the current supply chain issues in the marketplace, what is more readily available from the styles that you discussed today?
In general, all the DIN rail terminal blocks we carry we talked about today are available in stock here in New Jersey. Which style? I don't really want to generalize one over the other. However, I do know there's issues within the industry with material shortages, especially for spring and push-in terminals. We also have large numbers here in stock in New Jersey. They are available.
Oh, that's great to hear. Excellent. And to the audience, looks like for now we have one last question in the queue. So if you do have a question or a comment, now would be your chance to send it to us. And you can do that by adding it into the Q&A box and clicking submit. Okay, but for now, this is our last question, and here it is. Oh, wow, another great one. In light of manpower issues in the marketplace, we have a lot of repeat assemblies that need to be made. Do you guys offer terminal block assemblies for customers?
Great question. Yes, of course. If you have an assembly with several terminal blocks or even other components mounted on a rail, and that's repeated over and over again, you can send it to us. You can send us a list with the parts, a drawing. It's actually we do that quite a bit, so we'll give you a quote for assemblies as well.
Oh, that's great. Sounds like a very collaborative approach. And that was a great question. Thank you to the audience member that sent that in. Looks like that was our last question. We didn't receive anything more at this time, so we are going to move to close the webinar. So once again, I'd like to thank Marcus and the Altech team for that great presentation. Thank you, Marcus, for answering some questions from our audience as well. And of course, we'd like to thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch it again or share it with your colleagues. And lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we'll talk with you soon.